Hello my precious friends, I hope that you are doing great. Welcome to today's class. It's our 6th lesson on formula and variation. Now remember that in lesson 1, 2, 3, 4 and 5 we looked at formula. Therefore in this class we are going to look at variation. Now there are 4 essential types of variations. So we look at the types of variations, the types of variations. So the first type of variation is what we call direct variation. So we have direct variation. So what do we mean by direct variation? So this is simply a type of variation whereby an increase in one quantity, causes or leads to an increase in another quantity, So in another quantity. Similarly a decrease in one quantity, causes a decrease in another quantity, So this is what we are calling direct variation. For example, we can look at two quantities. One, I'm going to look at discipline as a quantity, Then the other quantity we are going to look at performance. We look at performance. We want to compare these two. Now, what happens if the level of discipline actually goes high? When the level of discipline goes high, we expect the performance to also go high. Similarly, or contrary, should the level of discipline deteriorate or go down, then you also expect the level of performance to go down. Therefore, we say that these two quantities are directly proportional to one another. So this is what we are calling the proportionality simple. This is what we are calling the proportionality simple. So these are our proportionality simple. So discipline and performance are directly proportional to one another. If discipline goes high, performance should be high. Should discipline go low, then we expect the level of performance to be also low. Therefore, an increase in one quantity causes an increase in another quantity. Similarly, a decrease in one quantity leads to a decrease in another quantity. Then mathematically, we can say that discipline, we can talk of discipline. Discipline will actually be equal to, then you multiply with a constant, then multiplied by performance. A constant multiplied by performance. So if you want to eliminate the proportionality simple, you simply substitute with equal sign, then of course with a constant. For this case, I'm using the constant to be k. So we can say that where k is simply the constant, where k is the constant of proportionality, Then how can you identify direct variation in a given question? So these are the key terms that should you see them in a question, then it means you are dealing with direct variation. So if you see terms such as directly proportional, then it simply means that you are dealing with direct variation. If you also see terms such as varies as, then it means you are dealing with direct variation. That a certain quantity varies as another quantity. It simply means that you are dealing with direct variation. Then we look at the second type of variation, which is called inverse variation. Remember, we said that we have 4 types, the 4 types of variation. So our second type of variation is what we are calling the inverse variation. So this is type 2. We have the inverse variation, inverse variation. Sometimes we can call it indirect variation. So inverse variation, also called indirect variation. So this is a type of variation whereby an increase in one quantity, leads to or causes a decrease in another quantity. It causes a decrease in another quantity. It causes a decrease in another quantity. Similarly, a decrease in one quantity, leads to or causes now an increase. It causes an increase in another quantity, So this is what we are calling inverse variation. That should one quantity increase, if one quantity increases, it leads to a decrease in another quantity B. Then if one quantity decreases, then it will lead to an increase in another quantity B. Maybe to understand this, we can look at two quantities in discipline. We look at a quantity called indiscipline, and that is indiscipline and performance. We look at these two quantities, indiscipline and performance. How do they relate? Now, should the level of indiscipline actually go high, then we expect the performance to be very low or to be very dismal. Then, should the level of indiscipline actually go down, then we expect a corresponding increase in the level of performance, whether it is academic performance or maybe any other type of performance, maybe in a given job environment, etc. Then mathematically, in terms of simples, this is how we represent it. Whenever we have inverse variation, we usually take the fraction. We take 1, then divided by the other quantity will always be on the denominator. So this one simply means that discipline is inversely proportional to performance. So 1 over is standing in for the term inverse variation or inverse proportionality. Of course, if you want to do away with the proportionality symbol, you simply introduce equal signs, then of course with a constant. So we can talk of indiscipline. Indiscipline will be equal to a constant, then multiplied by the reciprocal of performance. So we say that indiscipline is inversely proportional to performance. Of course, where k is simply the constant, where k is a constant of proportionality, Now, how can you identify inverse variation in a given question? You will see terms such as inversely proportional. Should you encounter terms such as inversely proportional, then it simply means that you are dealing with a type of variation which is called inverse variation. Now, the third type of variation is actually what we call joined variation. We have what we call the joined variation, which is simply a combination of either inverse and direct or any other types of variation. So our third type of variation, we call it joint variation. So joint variation is our third type of variation. Joint variation. So it's simply a variation. It is actually a variation variation that combines a variation that combines two or more variations, or more variation, a combination that combines other variations. For example, e.g., it can combine direct and inverse variation. It can combine direct and inverse variation. So that is what we call a joint variation. So maybe we look at an example so that you understand better. But if you find a combination combining either two or more types of variations, then it simply means that we are dealing with joint variation. The key terms that we expect is terms such as jointly. Should you encounter terms such as jointly, it means that you are dealing with a joint variation. Or maybe you are given one question, but that question is involving both direct variation and inverse variation, then it simply means that you are dealing with joint variation, because it is joining or it is combining various types of variations. Then the fourth and the last type of variation is what we call partial variation. So our fourth type of variation is what we are calling partial variation. So this is our fourth type of variation. It is called partial. We call it partial variation. Partial variation. But this one we are going to discuss it after we have dealt with the other three types of variation. So we deal with I'll give you the key terms that you need in partial variation. We'll be looking at examples on it. So for the time being, let's first of all look at joined, direct, and inverse variation. So let's look at an example involving the three types of variation. So we are given our example number 1, which is a past Kcse question tested in 204, paper 2, question number 23. It reads that three quantities PQ and R are such that P varies directly, so this is a direct variation, as the square of Q, and inversely as the square root of R. So actually this is what we are calling a joint variation, because it is combining both direct variation and inverse variation. So we are dealing with a joint variation. So given that P is equals to this, Q is this, and R is this, find P when Q is this one. So the first thing we need to do is to write an equation relating those two. So we are told that three quantities PQ and R are such that P is directly proportional, that is P varies directly as the square of Q. We are told that P is actually varying directly as the square of Q. Remember, the square of Q simply means Q squared. So this is what the first part of the statement means, that P varies directly as the square of Q. And we are told that inversely, so the same P is also varying inversely as the square root of another quantity R. So this one, remember, inversely we said you take 1 over, so this will be the reciprocal of the square root of R. So this will be the square root of R. So these are the two variations. Then because of and, we are going to multiply this particular 2. It simply means that we are combining the two types of variations. So it simply means that we are dealing with joint variation. So we are going to join these two, or to combine them. So to combine them, we are simply going to write as the quantity P is directly proportional to Q squared. So remember, and simply means you multiply. So multiplied by the other quantity is 1 over the square root of R. The square root of R. So if I simplify this, I'm going to have P being directly proportional to Q squared multiplied by 1. You'll simply get Q squared, then divided by, of course, the square root of R, divided by the square root of R. Then to remove the proportionality symbol, we simply introduce equal sign with a constant. So it simply means that P will actually be equal to, so remember this is part A of the question, P will actually be equal to k, where k is our constant of proportionality, multiplied by q squared, then of course divided by the square root of r. So this is the expected equation in terms of the constant k. Then remember, we are given quantities to find the value of k. We are told that p is 20 when q is 5 and r is 9. So this one is to help us find the value of k. Therefore, we are simply going to substitute the given values in our equation so that we find the value of the constant k. So if I substitute, I'm going to get the following. I'm told that p is 20, so this one will be 20 being equal to k multiplied by q squared. I'm told that q is 5, so this will be into, of course, 5 squared, then divided by the square root of r. Remember, my value of r is actually 9 from the question, so divided by the square root of 9. So this is going to give me 20. 20 is equals to 5 squared. I'm going to get 25, therefore I'll have 25k, so this will be 25k, then divided by the square root of 9, I'm going to get 3. Therefore, if I want to find the value of k, I simply multiply both sides by the reciprocal, so k will be equal to 20 multiplied by the reciprocal of 25 over 3 will actually be 3 out of 25. So it simply means that my value of the constant k will be given by 20, then of course multiplied by 3 divided by 25, which is going to give me 2.4. So my value of k is actually equal to 2.4. So it simply means that my equation, remember the equation was this one, we simply substitute k. It simply means that the equation connecting p, q and r will be given by p is actually equal to k, but the value of k is 2.4, so this will be 2.4, then of course q squared, so multiplied by q squared, then we divide with the square root of r, divided by the square root of r. So this is the equation connecting p, q squared, and of course r. So we are told to find the value of p when q is 7 and r is 25. So this one simply means that our value of p will actually be equal to 2.4. So this is 2.4, then multiplied by q squared. We are told that when q is 7, so this will be 7 squared, then of course divided by the square root of r when r is actually 25. So I substitute here 25. So this is going to give me the following: 2.4, then of course multiplied by 7 squared, I'm going to get positive 49, then divided by the square root of 25, I'm going to get positive 5. So this is going to simplify to it's going to simplify to the following. So I'm going to get the following. So if I take 2.4, then of course multiplied by 49, I'm going to get 117.6, then answer divided by 5, I'm going to get my value of p being actually equal to 23. So this is giving me 23.52, 23.52, or p can also be expressed as a mixed fraction, which is going to give me so 23.52 as a mixed fraction. I'm going to get 23, so either this one or 23 whole number, 13 over 25, 13 out of 25. So either of the two should be a solution. Then we look at part B of the question. In part B, we are told that if Q increases by 20% and R decreases by 36%, find the percentage increase in P. So we are going to find the new value of Q, that is after the increase. Remember, the original value of Q was just Q. So after the increase, we are going to have a new value of Q. So the new value of Q will be given by, so an increase of 20% simply means that 20 plus 100, which will give you 120. It's just like the profit. So an increase will be, so we'll take 120 divided by 100, then multiplied by the original Q. So it simply means that our new value of Q will be given by 120 divided by 100 if you take 120 divided by 100, you are going to get 1.2. So this is 1.2 Q. So this is the new value of Q. Then you're also told that R decreased by 36. So it simply means that you also have a new value of R. So the new value of R, a decrease by 36%. Remember, 100% is the standard value. So a decrease by 36 simply means that you'll take 100 minus 36 is like a loss, which will give you 64. So it means that the new value of R will be 64. So 100 minus 36, you get 64. So I'm subtracting because it is a decrease. Then this one I was adding to 100 because it was an increase. 100 plus 20, you'll get 120. A decrease, you subtract. 100 minus 36, you'll get 64. So this will be 64 out of 100, then multiplied by the original value of R, which is going to give you 0.06 for R. So this is our new value of R. So to find the percentage increase in P, you need to have the original value of P and also the new value of P. Therefore, it means that our new value of P, remember the original P in terms of K, it was given by this equation here. So this was our original P. This equation, this is what we are calling our original value of P in terms of K. So our original P was given by the following. So this was our original P. It was actually P is equals to KQ squared, then divided by the square root of R. This was our original P. Then we need to look for the new P so that we can find the percentage increase or the percentage change. So to find the new value of P, I'm simply going to substitute. So I'm going to have P being equal to, remember K is a constant, so it's not changing. So this will be K, then of course multiplied by Q, so Q squared. So but our Q squared, we have the new value of Q. So I'm going simply to substitute this one where I'm having Q. So where I have Q, I'm going to substitute with this value here. So I'm going to have the new Q, which is 1.2 Q. Remember here we are finding the new value of P. So this is new P. So I'll substitute the new value of Q that I've gotten, but because it is Q squared, I'll take 1.2 Q, then of course I square that, then divided by the square root of R. So I'm going to square root the new value of R. My new R is 0. So this is 0.64 R. 0.64 R. So this one should give me the new value of P. So it simply means that my new value of P, so P new will actually be equal to, this one simply means that K multiplied by, this one means that you are going to take 1.2, you square that, then you also take Q, you also square Q. So I'm simply separating the variables. So I'm also going to square Q separately. Then the denominator simply means that you are taking the square root of 0.64, then you multiplied with the square root of R. So this is going to give me, if I take 1.2 squared, I'm going to get 1.44. So I'm going to have 1.44, then of course KQ squared, then divided by the square root of 0.64, I'm going to get 0.8. So this will be 0.8, then of course the root of R. So if I simplify, this one is going to give me 1.44 divided by 0.8. I'm going to get 1.8. So this will give me 1.8. Then of course KQ squared. Then of course divided by the root of R. 1.44 divided by 0.8 is where I'm getting the 1.8. Now, once we have the original value of P and the new value of P, then we can find the percentage change in those two. Remember, this was the original value of P. Therefore, if we want to get the percentage change, we are going to have the following. So this is how we find the percentage change. Just like the percentage profit, you simply take the profit of a buying price, then multiplied by 100%. Similarly, the percentage increase in P is like a profit. We are going to take the profit, which is like the difference between the buying price and the selling price. So it's like the selling price will be our P new, then the buying price will be the original P. So the profit or simply the change in P, you are going to take the new value of P, then you subtract the original value of P, then you divide with original value of P, like that is the buying price, original value of P, then of course you multiply with 100%. So this one should give you the percentage change in P. So this is percentage change in P, percentage change in P. So the percentage change in P will be given by change in P is going to give us the following. So the new value of P, we already have it here. So this is our new value of P, which is actually 1.8. So this is 1.8 kq squared, then of course divided by the square root of r, then minus the original value of P, it was this one here. So it is kq squared, then divided by the square root of r, then divided by the original value of P was still the same, kq squared, then divided by the square root of r, then the whole thing of course multiplied with 100%. So this one can be rewritten as percentage change in P. Percentage change in P will be given by, remember I can factor out kq squared over the root of r because it is common. So if I factor it out, I'm going to have kq squared over the root of r, which is actually common, then into bracket. So this one will go here 1.8 times. So this will be 1.8, then minus kq squared over the root of r goes here one time because both values will cancel with each other. So it will remain 1. Then of course divided by, the original was kq squared divided by the root of r, then of course multiplied with 100%. Now if you are keen enough, you realize that k and k will cancel out, q squared and q squared will cancel out, the square root of r and the square root of r are both going to cancel out. So this one simply means that we are going to remain with the following as our answer. So we're going to get to remain with the following. So I'm going to have percentage change in P, the percentage change in P, change, remember the triangle simply represents a change. Percentage change in P will be given by, so I'm remaining with 1.8 minus 1. 1.8 minus 1, you are going to get 0.8. So this is giving me 0.8, then divided by, of course this one goes here one time, divided by 1, then of course multiplied by 100%. So this is going to give me 0.8 times 100. I'm going to get 80%. I'll get 80%. So remember, if you get a positive value, it simply means that the change is positive or there was a percentage increase. But should you get a negative value, it means there was a percentage decrease. Therefore, we are told to find the percentage increase in P. We are simply going to say that therefore P increased by 80%. So we know it is an increase because the change that you have gotten, the percentage increase is a positive value. If it was a negative value, then it means you will have said that P decreased by 80%. So in this case, the percentage increase in P was actually 80%. So in our next class, we'll be looking at further examples. Thank you very much for accompanying me until the end of this particular lesson. I do not take it for granted. In case you are new to the channel, kindly hit the subscription button and also turn on the notification bell so that whenever I upload a new video, you'll get notified. Until next time, this is